Welcome to Summarize Science. We often see advanced AI solving incredibly complex problems, but what happens when you interrupt them while they're thinking? A new paper from researchers at the University of California, Berkeley, asks this exact question: are large reasoning models interruptible? The answer reveals some fascinating and unexpected cracks in the armor of even the most powerful AI. Currently, most AI are evaluated in what's called a frozen world setting. You give the model a problem, it generates a complete response, and nothing changes in between. But the real world is messy. We get new information, correct mistakes, or just need a quick answer right away. This research challenges that old method by testing how AI handles interruptions, like sudden time constraints or in-flight changes to the task itself. The first strange behavior they discovered is reasoning leakage. When researchers gave a hard interrupt, telling the model to stop thinking and provide the final answer immediately, it didn't always listen. Instead of stopping, the AI would often continue its step-by-step thinking process, but hide it inside the final answer section. This could make the final answer up to 10 times longer, completely defeating the purpose of asking for a quick response. The next failure mode they found was panic. This happened when models were given a soft interrupt, such as a simple request to please speed up. Under this time pressure, instead of just thinking more efficiently, some models would completely abandon their reasoning process. They would then immediately return an incorrect answer, essentially panicking and giving up. Perhaps the most human-like failure they observed is called self-doubt. Here, the researchers would provide new, correct information halfway through the AI's reasoning process. Surprisingly, the AI would often distrust the new information, even when told to expect updates. As shown in this example, the model gets confused, questions the user's correction, and continues down its original, now incorrect, path. However, the researchers also found a promising solution for this specific issue. By adding a simple, targeted phrase in the model's own voice that confirms the update is verified, they could largely fix the self-doubt problem. This technique, called prompt guidance, significantly improved the AI's ability to adapt to new information. It shows that while these models are brittle by default, they can be guided to become more flexible. So, let's recap the important points here. Even state-of-the-art AIs can fail unpredictably when interrupted, exhibiting strange behaviors like reasoning leakage, panic, and self-doubt. This tells us that robust interruptibility isn't an inherent property of today's models. It's a capability that must be specifically designed and tested for. What this means for the future is that for AIs to become truly helpful assistants, they can't just be powerful thinkers in a perfect, frozen world. They must also be trustworthy and adaptable in our dynamic one. This work lays the foundation for building the next generation of AIs that can handle the messiness of real-world collaboration.